Okay, so question 9a gives us a function of f that is x sine x, and we're asked to find its derivative f dashed x. So hopefully you can recognize that this is a product rule. So our product rule from our data sheet says that dy dx equals u by dv dx plus v by du dx. Oops, sorry, du dx. So here we're just going to let u equal x. Therefore, du dx equals 1. And then we're going to let v equals sine x. Therefore, dv dx, according to our formula sheet, that goes to positive cos x. And we just need to start subbing it into our product rule. So dy dx is our f dashed x in this case. And that's going to be equal to u. So u was just x. Oops. And then we were going to multiply that by dv dx. So cos x. And then we need to add on to that v, which is sine x, multiplied by dv dx, which is just 1. So that's that guy. We had v in orange, cos x, which is dv dx in green, and u in the blue. So if we just neaten that up, that means that f dashed x equals x cos x plus sine x. Okay, so question 9b asks us to use the result from part A, which I've copied out up here, to find the value of this integral here with the domains of pi on 6 and pi on 2. And we need that in the form specifically of a pi plus b. So just two terms at the end of our question. So we're going to start off with just rearranging this result from part A. So if f dashed x equals x cos x plus sine x, like we found before, we can rearrange this to say that x by cos x equals f dashed x plus sine x. Okay, so I hope you've just seen that I've rearranged that by moving the sine x, and minus sine x, from this side to this side. So now we can integrate this with respect to x and integrate all of this with respect to x. And we should get that that equals the integral of x cos x dx. And that's what we want up here, is the integral of, well actually I'll evaluate this one. So that's just going to be f of x, f dash goes to f of x, and negative sine x from our data, or our formula sheet, goes to negative cos of x. And technically you'd have a plus c value there, but we can just let that be 0 or ignore it, because when we're doing our evaluation of our definite integral, we'll go f of b take f of a, and any c's within those would just cancel anyway. So we don't need to worry about a plus c term there. So we'll just get rid of it completely. So neaten this up, and we'll pop in our domain. So pi on 6 to pi on 2 of x cos x dx is going to equal, so f of x we were given as being x sine x. So we can substitute that in. I haven't pulled that from anywhere. That was given to us. Given to us right up here. That's nothing special. So that was just given to us there. And then negative cos x is just going to be positive cos of x. And again, we're going to evaluate that between pi on 6 and pi on 2. So again, that's the same as capital F of pi on 2, subtract away capital F of pi on 6, where capital F, these guys, is just our entire antiderivative that we found in there. So let's go ahead and plug this in. So we get our first one, I'll do in blue, is our f of pi on 2. So we have, wherever there's an x, we put pi on 2 by sine of pi on 2 plus cos x, where the x is replaced with pi on 2. And then in the green, we're going to subtract away our f of pi on 6 case. So we're going to have pi on 6 there. We're going to have sine of pi on 6. And we're going to have plus cos of pi on 6. Alright, so now it's just a matter of finding the exact values of our sine and cos ones. So for the pi on 2 case, that's the 90 degrees, or a quarter into our sort of period on the function. So if I just graph sine roughly and cosine roughly across, that's a period of 2 pi, period of 2 pi. So sine of pi on 2 is going to be 1, and cos of pi on 2 is going to be 0. So again, that's 1 and that's 0. And now we've just got to work out our pi on 6 case. So that's where you might want to set up those useful triangles. So there's our right angle triangle. That's 2, that's 1, that's root 3. Now we know the smallest angle is the pi on 6, and that goes opposite the smallest side. And then our largest angle obviously is pi on 3 in there. So we're dealing with the pi on 6 case exclusively in the green, so just this. We know that sine is opposite over hypotenuse, so the opposite of this is 1, and the hypotenuse is 2. So sine of pi on 6 is just 1/2. Cos of pi on 6 is the adjacent root 3 on the hypotenuse 2. So clean this up, and we should get that this is equal to pi on 2 times 1 plus 0 minus pi on 6 times 1/2 plus root 3 on 2. Again, we can clean this up just a little bit more, so we can make that equal to pi on 2 minus pi on 12. When we multiply 6 by 2 on the bottom line, we'll get 12. And then the minus sign comes across and we get minus root 3 on 2. So it's not quite in the form of a pi plus b, so we're going to need to combine these terms together to give our a pi, and we're going to need to leave this as our b term, all the way from up here and here. Alright, so let's do that, and we're just going to get that this integral is equal to, so pi on 2 would be the same as 6 pi on 12, so 6 pi on 12 minus pi on 12, so I'll write that out. 6 pi on 12 is the same as pi on 2, minus pi on 12 is going to give us 5 pi on 12, and we're still subtracting away root 3 on 2, so that's just equal to 5 pi on 12, and then we subtract away our b term, which is 3 on 2, and that's the answer to our definite integral for this question.